Welcome back to Easily Explained, where today we will be talking about interpreting graphs of functions. So let's get started. So when we are given a graph like this, we've learned that all of our domain values go on the horizontal x-axis, while all of the range values go on the vertical y-axis. So the domain has all of our independent variable values. So if we're given an actual situation, for example, if we're given this graph with the situation where the time is our domain or x values and the distance covered is the range values, the independent variable would be time, and the domain values are graphed along the x-axis, so the independent variable values will also be graphed along the x-axis. When we're given the specific values on the x-axis, we can also write an inequality for the domain of the function. So the domain would be all real values of x, where x is greater than or equal to 0, and less than or equal to 6 is our largest value here. And if we're given the range values, we can write a set, all real values of y, where y is greater than or equal to 0 again, and less than or equal to our largest value here is 300. We can also tell from a graph whether it is continuous data or whether it is discrete data. So continuous data is that the points in the graph are connected and there's no breaks. Whereas if we had discrete data, we might have like 1 point here, and then to 1 point here, and 1 point here. This is discrete. It's not continuous and it's not connected. Now let's say we're also given a different type of graph. From here, we need to be able to identify our relative maximum, relative minimum, absolute maximum, and absolute minimum. So let's go over all of these regarding this specific graph. So when we're talking about an absolute maximum, it's basically exactly how it sounds, the absolute maximum that the graph goes up to. So if we look at our highest point in the graph, it's right here. So this right here is our absolute maximum. Now let's identify our absolute minimum. Same thing, we just look at it. The absolute minimum is just right here at the very bottom, at the very starting point. Okay, those were easy. For relative maximum and relative minimum, we just need to find a greatest value of the function for a limited domain. So if we just take, for example, 0 to 2. Now, if we just look at this part of the graph, we can see that there is a maximum, this point right here. So this would be a relative maximum. Now, if we take another domain value and we take this value, we'll see there's another relative maximum right there. And the same will hold true for a relative minimum. Now we just need to take some specific domains and see that there's a relative minimum right here. And also, if we take, for example, these values, there's one right here. Now for practice, I will be giving you a graph, and from that graph, you're going to identify the set of domain and range values first. Then you're going to identify the absolute maximum and minimum, and the relative maximum and minimum. And then lastly, decide whether the data is discrete or continuous. And for the domain and range values, if you're having trouble, go rewatch our previous video that covers more in depth about domain and range. Pause the video now, copy down a graph that looks similar to this one on the screen, and then complete the practice. Alright, so I'm going to start by identifying the domain and range. So our domain, all real values of x, where the domain values go from 0 to 5. So it should be 0, x is greater than or equal to 0, and less than or equal to 5. And for range, all real values of y, where also starts from 0. And this one, the greatest value is 40. All right, now let's identify absolute maximum. So this value right here is the highest point, and that is basically where y is 40. All right, and an absolute minimum, the lowest point, again, 0. And now for a relative maximum, we can look at the domain from 0 to 2 and see that 20 is a relative maximum. And we can't really tell from this one, but if it were to continue on like this, then yes, we could consider this another one at 20, where it's at 5. And the last one is relative minimum. So for minimum, if we take these same values, 10, and this one kind of goes down a little bit, so we could round that to be about 8. And the very last thing we need to decide is whether the data is discrete or continuous. And since it continues on and it'll keep going, we're going to call this a continuous data set. Congratulations, you are now an expert at interpreting graphs of functions. We hope this video really helped, and we'll see you guys next time. Bye!